Hi there, welcome back to my channel. In this video, I'll be taking you through the fundamental theorem of calculus. If f is continuous on the interval ab, then f of x is equal to the integral from a towards x of f of t dt is continuous on ab, differentiable on ab as well, and the derivative of f of x, this one is capital F, right? Capital F of x. So let's see. So let's see. This one is capital F over the x is equal to d the x of the integral from x to a f of t dt should give us f of x. Now this looks messy, right? So let's break this down. All that this is trying to say is we have a function f, right? This is a function smaller f, right, which is continuous over an interval, and this is a closed interval, meaning the endpoints are included. Then there is a bigger f function, capital F, right? Capital F function, which is equal to the integral of an unknown function of t from a, which is the endpoint, one endpoint of this, to x, which you don't know, right? So this has been defined that our capital F of x is defined as this, okay? That is one thing you have to take note of. We are saying that our capital F of x is defined as this, and it's also continuous on the what? On a closed interval and differentiable over the open interval. So now you know that our small f is just a continuous function on what? An interval ab. A bigger function is defined as the integral from a to x of unknown function f of t dt. Then that same function should be continuous over this and differentiable over this. Then the derivative of this bigger function, which is the same as the derivative of this integral function here, will give us our what? Smaller f of x back again. That is the concept, okay? So it's like the reverse of differentiation. That is all that they are trying to say. You have this function here and it's defined as this. When I differentiate this function, I'll still get what? My f of x back, right? Get my f of x back. So if you want to solve any problem concerning fundamental theorem of calculus, then you should express your bigger function as what? Integral from a to a particular what? Variable, right? And that variable that it will reach is what becomes the argument of our main function. Look at it. Here is f, capital F of x, and here too is x. So if I change here to t, there should be t here. If I change here to p, there should be p here. That is one thing, okay? So now let's solve an example here so that you understand it better. The example is saying that we should find the derivative of this integral 5 to 2x minus 1, 3t sine t dt. Right. Now, is this function here, is it indeed representing the capital F of x? If it's indeed representing it, then we can just go straight ahead and say that the answer is simply what? Yeah, what I have here. But no, it's not like that. So we realize that there is 2x minus 1, but here there was x, meaning that we have to represent this whole thing. Because I initially told you that whatever is up here becomes the argument of what? My bigger function. So I can't say f of 2x minus 1, no. So you let's say v to be equal to 2x minus 1. Therefore, our question becomes d of the x of the expression integral from 5 towards v of 3t sine t dt, right? So sine t dt. So at this point, since I have brought v here, I can then take this off and make it what? Capital what? F, right? So the capital F of v over the x will be equal to what I have here, which is 5v 3t sine t dt. So now I've been able to make this the subject here because I know that whatever is up here becomes the argument here. Okay, right. So now let's see. Now I'm having integral of this expression But see something, this v that we made the subject. The question is asking us to find out the derivative with respect to x, not v, right? So um we realize that we have to apply the chain rule here. We have to apply the chain rule here. So meaning if I want to find the f, if I want to find the f of v over the x, this should be equal to the f of v over the this should be equal to the f of v over what? Dv times dv over the x, right? So this is a nice chain rule, is that not it? Because after making our upper limit the subject with v, we realize that this whole expression, instead of d of dx of this integral, becomes d of what? A capital F of v over the x is equal to this. But using the chain rule, realize that this expression here, we can break it down as the f of v over dv times the v over the x, and it still gives us the same thing, right? So let's see how we do it here. So once you have your chain rule, I think you are almost done. Okay, you are almost done. Remember that the fv, our function of v with respect to v, meaning this thing will become what? V, right? So that will simply give us 3v sine v dv. Wherever you see t, you put what? V there. That is all. Then times our dv on the x. What is dv on the x? So when I made v equals 2x minus 1, I can find my dv on the x from that side, okay? And that will be equal to what? Dv on the x will give me what? 2. As simple as that. So I have times 2, right? So this will give me 6v sine v dv, right? 6v times v dv. Is that not it? Yes. So at this point, let's see. So there's no need bringing the dv because that is a signature of what? The derivative. Sorry, the integral. So there wouldn't be any dv here. So let's see. I'll take this out here. Yeah. So at this point, since I have 6v sine v, and I have been able to express my dv fv or dx, then the only thing I have to do is to bring my substitution, because I wasn't given v. So 6 multiplying 2x minus 1 sine 2x minus 1. And that is the end of this tutorial. Thank you for being with me. Please don't forget to like, subscribe, and share.